Now that we have discussed different storage objects that are used in the memory stack, now let's try to understand what are the different block management types that are present. So when we refer to block management types, what we are referring to here is the way the blocks are used. So we have the availability of the four different types of storage objects, and how can you use them in a combination. That's what we mean by block management types. So broadly speaking, the block management types are divided in this fashion, that is native, redundant, and dataset. So each of these has its own properties, and we will discuss now each of them. The first one is native NVRAM block. So this is the most simplest we can say. Here one single NV block is used. Okay. So that's the peculiarity of this NVRAM block. We just need one NV block to use this management type. And as a result, it's having minimal overhead. We don't have that much complexity here. It's simple. So minimum overhead is another factor. Now it provides 1:1 mapping between RAM block and NV block. What this means is that for each RAM block, we will be having one NV block. So the 1:1 mapping is what that brings us to. So that's all. There will be one RAM block and one NV block, and they will be mapped to each other. That's all about native NV RAM block. And apart from that, let's try to see the other storage objects. So NV blocks will be having count 1. RAM block can have the same value 1, and ROM blocks can vary from 0 to 1. And we can have an administrating blocks of count 1. So I guess you understand that part about native NVRAM block. Let's move to redundant NVRAM block. In redundant NVRAM block, we have two NV blocks. Okay, so that's the main difference from native NVRAM block. There we used to have just one NV block, and here because of this two NV blocks, we will have more overhead because we are now using one more extra block in the NV side for extra storage. So here we will have 1:2 mapping of RAM block to NV block. So for each RAM block, now there will be two NV blocks that are created. So what is the use of this extra NV blocks? So let's see. The second block is used for redundancy. So that's all. I mean, this is a backup copy. It's not some new information. The second block data is basically present for redundancy. So we have a backup copy when the first block is corrupt. So we can also see, this is the same thing. If the block is defective, second block is read instead. So this kind of block management type is mainly used when there is some safety critical application. So we cannot afford to lose this data. So that's why we are keeping the data as backup. Okay. Okay, let's look at the storage objects again. The NV blocks is 2 here because we have a redundant copy. RAM blocks is 1. ROM blocks can vary from 0 to 1, and admin blocks is 1. Okay, so we can move to the next one. Next is dataset in VRAM block. We briefly discussed what is a dataset in previous lectures. The dataset is basically an array of equally sized data blocks. So we have a combination of different blocks stacked together, and they can be accessed by something called as an index. So read and write location is identified by an index, and it's called data index. Now because we have multiple blocks, so we'll need multiple NV blocks here. So because of that, for each RAM block, now we'll have n NV blocks. So so the memory requirement is more because we have multiple blocks, NV blocks created for each RAM block, and these can be accessed by the data index. Now the total number of configured datasets that includes the NV plus ROM blocks must be in range 1 to 255. So there is a limit to the maximum number of configured datasets we have, and it can range from 1 to 255. So here is the storage objects for this particular block management type. NV blocks can vary from 1 to NVN block num. So it's basically a upper limit. So the main point is that we have to maintain this 1 to 255 range. So we can manage with NV blocks and ROM blocks. So here, as you can see, 1 to NV block num, and in ROM blocks there is 0 to NVM ROM block. So this sum can be adjusted, but finally we will have a 1:n relation between the RAM block and ROM block. So as you can see here, RAM block is 1, whereas the NV blocks is varying. Finally, admin block is again 1. Okay, I guess we can go to the summary then. Let's summarize the different block management types we discussed today. The first one is the native NVRAM block. The native NVRAM blocks can be used if only a single block is required to store the data. So this is the simplest use case. So if the requirement is such that we just need to store the data and that's it, go for native NVRAM block. There is no further problem. But in case of cases when there is reliability or safety is a concern, then a backup copy is required. And so because the backup copy is required, redundant NVRAM blocks is a better choice. Then finally, we have a use case when the environment itself changes. So for a car, if there can be different variants, and for each variance there can be different parameters that gets varied. So in that kind of scenario, the dataset is more useful. So the dataset NVRAM block can be used in this particular scenario.